Thanks for tuning in to This Automation Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week, we discuss technologies used in automation. This week, Sean Fierer, mechatronics specialist with SKF, is here to discuss electromechanical actuators versus pneumatic. Thanks for joining us today, Sean.
No problem. Thanks for having me.
So, when we're looking at a pneumatic actuator versus electromechanical, there's some obvious differences, but let's back up, I guess, and kind of describe it for our listeners.
Yeah, I mean, obviously with pneumatic, you've got fluid power controlling your thrust load. So you add pressure on one side of the cylinder, and it pushes or thrusts the cylinder forward. With electromechanical solutions, you're looking at typically a ball screw or Acme screw drive. So the motor is directly driving the screw and directly thrusting the load. So one is fluid, one is electromechanical.
Cool. Okay. So when it comes to control, a lot of people maybe know pneumatics and you've got a valve on and off. How can you control an electric actuator? What are options?
Yeah, absolutely. And there's a lot of different options, but it always starts with the type of motor that you'll pick. So you may pick either a stepper motor or servo motor. The most basic actuator can actually just be used with a brush type motor, DC motor. But that allows you, and depending on the type of motor, it allows you to really adjust the actuator to the application that you're using. If it's heavy duty cycle, if it's a lot of motion profile where it's velocity changes and acceleration changes, probably a servo motor is ideal. But it does allow you with the electromechanical solution with the motors to program different locations within a stroke length versus pneumatic, which is more difficult to set up for different stroke lengths.
Yeah, I know that's definitely very difficult trying to hit your valve timing in between travels to get the pneumatic actuator. That's kind of what we've experienced in the past.
Yeah, and the repeatability as well. The accuracy of the positioning is ideal with the electromechanical solution. And there's multiple feedback systems. You can have a rotary encoder, you can also have a linear encoder. So there's many different feedback systems you can use with the electromechanical solution.
Oh, I've seen a lot of rotary encoders on motors. The linear encoder, how does that typically tie into the control system?
Well, that would typically tie in, well, first of all, I think it's more important of how you would mount it. And it's going to be mounted directly in line with the load and the position of the actuator. So it's going to be able to give you direct feedback as to the exact location of your point that's being moved. And typically, most motion control devices, controllers can handle that kind of I/O for the positioning of those, and then give feedback to the motor and make sure the motor's where it needs to be.
Okay, and those are pulse output just like a rotary encoder, or are there other options or other type of outputs?
Typically pulse option would be
Okay.
ideal. Yep.
Nice. And I'll back up. You mentioned a couple of different types of screws. There's Acme screw, ball screw. I think I'd heard of a couple others. I know there's lead screw and roller screw. How do you know which screw to pick?
Absolutely. That's a great question, and a question that we get asked quite often. Typically, you're going to start with the most basic screw. That would be an Acme screw, and that's a sliding screw. So you've got basically either a brass nut or a resin or plastic nut on a steel screw, and it's typically square form threads. And that's a good screw. It's got very good load capacity, but where there's a disadvantage for that product is the fact that it's high friction. So your actuator may draw quite a bit of current with an Acme screw product. But the other advantage of that product is it could be self-locking as well. So meaning if the load, if the power goes off, the actuator probably will not backdrive because you've got a lot of inefficiencies due to the friction.
Okay.
The next type of product that we would go to for higher duty cycles, better performance would be a ball screw product. And again, that's when you go from the Acme screw that's got the sliding performance to the ball screw that's got rotating elements internally, so you get much more efficiency with a ball screw.
Okay.
And depending on the gearbox, you can also have self-locking systems with a ball screw product, but you really get the efficiency and the lower power input because of the rolling contact of a ball screw versus an Acme screw.
Okay. So if you use a worm gearbox with a ball screw, you've got that locking kind of ability built in from the mechanics.
Absolutely.
Okay.
That's exactly right. So it depends on the gearbox that you would use.
Okay.
Yep.
Gotcha. Is lead screw, is that a generic term that would include Acme, kind of like a square is a rectangle, or?
Yeah, a lead screw is a term that would basically encompass balls. It would encompass lead the Acme screw product. So yes,
Okay.
lead and Acme screw are typically kind of interchangeable.
Okay,
Yep.
gotcha.
Yep.
And then roller screws, when does that come into play? Because I
Yes.
see it less often, but it comes up.
Absolutely. Roller screws would be in a situation where, and we talked about electromechanical versus pneumatic. When we start to talk about hydraulic cylinders where you've got multiple tonnage of thrust loading, that's when, if you've got a customer that wants to go from hydraulic to electromechanical, then you're starting to talk about kilonewtons and thousands of tons of load, and that's where the roller screw technology comes into play. The roller screw operates like any other type of ball screw or Acme screw, where you rotate the screw and the nut translates linearly. But what it does is there's many more contact zones between the roller screw nut and the screw, which gives you the load capacity and the stiffness that would be required to replace hydraulic systems.
Okay.
So that would give you an electromechanical solution that could potentially replace hydraulics in many applications.
Okay. Is with more contact points, is there more friction then, or is it actually more efficient?
No, that's a great question. It's actually more efficient because you still have rolling contact,
Okay.
and this is a very precision ground product and technology. So the efficiency of a roller screw is actually a little bit better than a ball screw would be.
Wow, that's impressive.
Yeah. So you could actually also have applications where, if you wanted the product to backdrive under load, the roller screw is ideal because it would allow that kind of a backdrive because it's an extremely efficient product.
Okay.
Yep.
Interesting. Cool. How about any types of IP rating? Is one of these screw technologies better than the other, or are they always contained and that's the way to do it?
That's a great question. If it's a screw with no protection on it, typically if you've got a washed down environment, probably an Acme screw, a stainless Acme screw with a bronze nut, something like that would be ideal. Now the roller screw technology is used in a lot of aerospace applications where there's a lot of nasty environment and contamination and corrosion and dust and debris. The roller screw does very well with those type of applications where the contamination is very high. But what I would say in general is that most actuators have what we call protection tubes that would cover the ball or roller screw or Acme screw, and typically those are going to be IP54 or better rated. So you're talking about certainly splash rated, but also we do offer some actuators that are pressure wash rated as well.
Well, cool. Good. Well, I think that's a good overview, and it would get people off on the right foot. So that's all we have for this week. Thanks, Sean.
You're very welcome.
And thank everybody listening to This Automation Life from Brenner-Fiedler. Be sure to continue tuning in each week. We've got some upcoming episodes. We're discussing motor starters and some various other sensor technologies out there that kind of a little more hidden than the photoelectric. So any additional questions on actuation, feel free to email questions to us at tech@brfa.com. Thanks.